Hello everybody, this is High Voltage Concepts, and today we're going to review the E-beam systems that High Voltage Concepts builds. And in front of you, you'll see this is an HVC EB6, the second one down on the list. The top one is a 3 kilowatt, makes 6 kV, and also 500 mils for 3 kilowatts. This power supply, which is the dash 6, is a 10 kV power supply, and it makes 600 mils. And then the last two you see are the 8 and 10 kilowatt, which they're all 10 kV, and the 8 makes 800 mils and the 10 makes 1 amp. Also, the 8 and the 10 can run 1 or 2 guns. The first two, the 3 and the dash 6, have flying high voltage leads. They could run 1 gun. Alright, today I'm going to show you the operation of this power supply, and we'll start off by when the circuit breaker is turned on. Initially, for the very first time, there's approximately a 35-second delay for the driver to come up to power. Or once the breaker's on, there's no delay for you to turn high voltage on. And as you can see, we have a series of faults that can occur. This negative light represents the polarity of the power supply. All the E-beams are negative. This fault light, if any one of these faults is triggered, an interlock, over temperature, because the power supply monitors its own temperature, over voltage or over current. These almost never fire. If these fire, it means that the regulator somehow got out of control. The last one is a driver. That could be an overcurrent, a short circuit on the output, or it could be a very high peak current. For instance, if you're trying to draw full power down somewhere at 4 kilowatts or 3 kilowatts, something of that nature. Alright, the next thing I'd like to talk about is the function of some of the buttons on the front panel. This is, if you hold this button down, this is the preset, and you can see where the voltage set point is. This is approximately 5% accurate, and this you can set and say, I want to go to 5 kV, so you would turn this up to 5 kV, and then this is before high voltage on, and then release the button. Then if you turned filament and high voltage on, it would go to 5 kV. Right now we're going to operate down at 3 kV just for demonstration purposes. And this is the current set point. This is how much beam current you want, and this is also adjustable, and anywhere on this power supply up to 600 mils. Filament current has 3 regulation points. It has, when you turn filament on, which we will do now, you can see there's approximately 15 amps there. This is what's called a standby or a preheat condition, and what this does is it turns on the filament just before high voltage, so that the filament itself in the gun is not shocked from being ice cold to going into regulation. It also speeds the entry point into the regulation because the filament is preheated. This value is approximately set for about 10 amps on the 3 kilowatt because the filament is a little bit lighter. We set it at around 15 on the 6, and on the 8s we set it around 20-22 amps. These are all just below the dark region where you have enough heat so that you don't thermally shock the filament, but yet you're not emitting any electrons because you're still in that dark zone. But yet you're very close to the operating point of a very low current set point. Okay, so what happens here in this case, we would be ready to turn high voltage on, And as you can see, if I don't turn on the filament and I try to turn high voltage on, nothing happens. because we need to have the filament on first. So the power supply knows that you need to do this sequence. Once we turn high voltage on, power supply will go to the assigned voltage, and the current output, we have a resistive load now. So right now we're below the current set point. If I raise up the set point, and this is on a resistive load, what happens is you see the filament turn on hard to try to make electrons to get up. It can't do that because we're not on a gun. If I go below that set point level, the filament turns off. This is what you're seeing is the regulation of the filament to make current on the output. The current is fixed here because we have a fixed resistor and we're not on a gun. So that's why if I raise this up, you see that filament turn on. If I go below the set point, you see the filament turn off. Now, I can turn off high voltage, and then I can turn off the filament. Or I could turn off the filament, turns off both. Right? Now, the next thing I'm going to show is a remote operation. Remotely, we're going to put in a 10 to 24 volt signal. After selecting we want remote, and when we put in that signal, the power supply will sequentially turn on by itself as you're demanding high voltage. As long as you're holding that signal to the remote, this power supply will turn on. Once you remove that signal, high voltage goes off first, and then the filament will turn off. The only thing is that when you go into remote, current adjustment is via remote. So the voltage adjustment always stays on the front panel. This is to counter your magnet, which usually doesn't drift that much. So right now I'm going to ground the pin. And now we're going to, if I try to turn on high voltage, I can turn the filament on, but you'll see I'm on remote mode. I can't turn high voltage on. Okay, so now we're going to apply high voltage via remote. Filament comes on, and then 6 to 7 seconds later, we end up with high voltage on. And you can see I can control this here. I cannot control the current. The filament is demanding more power. So here's how we turn high voltage off. We remove the signal. High voltage off first, then filament off. Now the last thing I would like to show you, we're going to go back onto local, and we're going to turn high voltage on, and I'm going to show you arcing condition. With the power supply on, we're going to arc the output, and you can see the rollback. Okay, now what if I have a dead short? Power supply shuts off. And that is basically it. The full operation of the HVC EB-6 or any of the others that are listed, they all operate the same way, with the exception of the 8 and the 10, which has the filament box in a remote location right under the chamber. And the first two have the flying lead because usually the systems are much smaller. Thanks for watching. My name is Jay. I'm the CEO and Chief Engineer, and this is High Voltage Concepts. Thank you.